There are four known fundamental forces of nature: gravitational, electromagnetic, strong, and weak nuclear. All of them are non-contact forces. We have learned about gravitational and electromagnetic forces. Both of those are inverse square law long-ranged forces. The forces are proportional to 1 over r squared. The farther away, the weaker the force. But the decrease in the strength of force with distance is gradual. Gravitational force is by far the weakest of the four. That's why most of the time we could ignore gravitational force when we studied electricity and magnetism. But gravity is also the only one of the four that acts on all particles with mass. It cannot be shielded, and it is always an attractive force. Electromagnetic force is also long-ranged like gravitational force, but the electromagnetic force is much stronger. The contact forces such as tension, normal force, friction, etc. are all fundamentally electromagnetic forces. For example, when we pull on a rope, the cohesive electric forces between atoms in the rope attract and pull on each other to provide tension. When we place a book on the tabletop, the atoms in the tabletop become compressed out of their equilibrium positions. The electric forces between the electrons and the nuclei in the tabletop create restoring forces that push upward on the book, and that is the normal force. Electromagnetic forces also fundamentally determine the properties of chemical elements and all chemical bonding. Next, let's look at the strong nuclear force. We will use a very stable atomic nucleus, iron 56, as an example. In an iron 56 nucleus, there are 56 nucleons, 26 protons plus 30 neutrons, all crammed into a size of about 10 to the negative 15th meters. Neutrons are electrically neutral, but the protons are all positively charged. This means the protons inside a nucleus must exert very strong repulsive electric force on each other. So there must be an even stronger attractive force to overcome the repulsive electric force and hold the nucleus together. This force is called the strong nuclear force. The strong force is much stronger than the electromagnetic force. It is attractive and it acts between all nucleons. The strong force is very short-ranged, about 10 to the negative 15th meters within a nucleus. Because as soon as a proton gets out of the nucleus, the strong force is no longer effective and the electric repulsive force would prevail. As for the weak nuclear force, it is weaker than the electromagnetic force and even more short-ranged than the strong force. It is involved in the radioactive decays of subatomic particles. We will not go into details here because it is not in the AP Physics B curriculum.